and that it's streaming. You can do it on your phone or whatever. It's gonna take a little while. Once this comes up, it'll be ready. All right, it says that we're live. Anybody see it?
Yeah, I see live.
Right, but you see the class? Okay. All right, so now, let's go to our notes. Chapter 4. All right, chapter 4 is making a decision. That's gonna be our condition. All right. So now, it tells us that, and like I say, it tells you at the top what we're gonna be dealing with ifs, nested ifs, if else, etc. All right. So how many people? All right, everybody's saying that. Okay, I didn't quite understand. How many people going through the chapter and reading through those notes and looking at those notes? Doing those end of the chapter quite example. Gotta do that. That helps. Huh? Yeah, and the check. Okay, and does it help though?
Yeah, I only did a couple of them. That's all I had, a couple of them.
Right, you see what I'm saying? So try to go through all of them, and go back and forth, and it helps. It conditions you to not make some of them same mistakes. I didn't turn my phone on. Some of them same mistakes that when you're taking that test and they give you those examples, and you're like, oh, I don't know what to do with this. All right? Now, because I can't give you a program with every single detail all the time. I try to give you something to accomplish. So let's look at this. Relational operations, all right? So it's saying what we're gonna be doing, we're gonna be relating or comparing things at this point. So it's a relational operators allow you to compare numeric and char values and determine whether one is greater than, less than, so see where the max scale is gonna come in, not equal to another. Everybody understand that, right? So, like I say, your max scale is gonna have to be somewhat tighter. Now, you say, well, Mr. Vester, I know 2 is greater than 1, right? Now, in computer science, now you're gonna have to write it out. It's all right to know that 2 is greater than 1, but now you have to ask a question if 2 is greater than 1. And if you mess up on your signs, what you doing? You're not asking the right question, right? Everybody understand it? So that's why you need to understand those operators. So let's say so far the programs you have written follow the simple scheme. All right, gather input, perform one or more calculations, and display, right? Get the data, calculate it, and output it, right? That's all we've been doing. Now what we're gonna do is almost like I tell you, okay, or your parents say, okay, I want you to go to Walmart, right? All the streets are clear, and when I say clear, no construction or whatever. You can what? Just go what? Straight to Walmart, right? But what happens if a road is closed because of construction? Now what happens? You're gonna have to know how to make a decision as to which way might be the quickest, which way might be the best travels, etc. Correct? So now it's like, oh, if this way or this road is closed, then use this alternate route. All right? So that's what we're gonna be dealing with computer science. If a number is whatever, or if a name is equal to whatever, or if this is not equal to whatever, then we're gonna do something. All right? So computers are good for performing calculations, but they are also quite adept to comparing values to determine if one is greater than, less than, or equal to the other. These types of operations are valuable for tasks such as examining sales figures, determining profit and loss, checking the number to ensure it is within an acceptable range, and validating the input given by a user. All right? So, the validation part. If I told you to, you've all seen it, when you go online and maybe you have to do a purchase of something. It might ask you, what year were you born, right? Why are they asking that? Huh?
Age verification.
Right, the age verification. They want to verify that you are old enough to make that purchase or whatever. Or sometimes they might say, are you 18 or older? You understand? And based on the value you put in, it has to check to see if it's greater than that value or less than that value, you will do whatever. All right? So, let's look at some of the operators, all right? So look at this. This is the greater than operator, class. When you write in the program, if I had X and Y, and I had X and then Y here, that would say X greater than Y, okay? This is the less than symbol, okay? It's pointing to the left, right? And if I had X and Y again, X less than Y, okay? Look here, greater than or equal to. Everybody got that? That's not and. Greater than or equal to. So if I had X on this side and X was equal to 10, and if I said 10 here, X greater than or equal to 10, would that be a true or false statement?
True.
That would be true. All right. So see how you have to understand your math concept in order to program. So now, look at this. Less than or equal to. All right? So if I had the same thing, X equal 10, and then I say X less than or equal to 10, that would be true or false?
X is still 10?
Right.
That would be true.
True, because I'm including 10 equal to, right? Less than or equal to. Correct? Everybody get that? Right. If I did this, I'm gonna open up online GDB just for the sake of it. Okay. And what I was saying is, all right. What I was saying is this. Okay. All right, I said X was equal to 10. Then I said something like if X is less than or equal to 10. All right, if I can type it. All right, now what I would have to do is I wanna say all right, so looking at this, what's your name is what?
Grow.
Ms. Grove. Here, X is equal to 10. Look at this question. If X is less than or equal to 10, that would yield what?
True.
True. So what happens is, when I have my curly braces right after my if, that's what I'm gonna do if it's true. Okay? So if it's true, I'm gonna print out what?
True.
True. If it's false, what I'm gonna do?
No.
Nothing. Okay? So that's just an if condition action. If it's true, do this. Otherwise, just continue with the program. All right? So if I run this, it just should say what? True. All right? All right. So see, it printed out true. But what happens if I said 11? If I made X equal to 11?
It wouldn't print out it.
It would be false, right? 11 is not less than or equal to 10, correct? So it just continue, return 0, and that's it, nothing. So if I run it, you'll get nothing, all right? Because I didn't have any conditions, see? Nothing. All right, so any questions? All right, now look. Remember, we had X equal to 10. We do our assignment statements, right? Now we looking at a what? Equal, equal. This equal compares to values or variables. Everybody understand it? If I use one equal, I'm assigning. If I use two equals, I'm comparing. Got that? Okay, let me show you an example. All right? I'll leave this, I'll leave it at 11. All right? So, if I do this, what happens if I do this? It assigns x to 11, and then in what? It acts as what?
Is x equal to?
If 11 is equal to 10, is 11 equal to 10? No. So what's going to happen? Nothing, right? Everybody understand that? But check this simple thing out where you can mess up. In the back, hey, you need to pay attention because y'all, I'm telling you, y'all gonna run into this problem. If I simply do this, what am I doing to x at this point?
Assigning it to.
I'm assigning it, which will make that if statement what? True, always. Because what I'm saying, x is equal to 11 here, right? And what I'm saying here, x is equal to 10, right? So I'm making it true. So what's going to happen if I run this? It's going to print true.
This was on solo there.
Ma'am?
This was on solo there.
Yes, listen, I understand that. Solo Learn is just a added link to help or to guide you.
I know, I'm just saying that it was on there.
Oh, okay, right. Well, like I said, the more you are introduced to this information, hopefully the more you the better you can retain it. All right. So that's why we give you several links so that you can say, well, oh, I did this on this. I did. But if you don't do any of them, you know, you just going on the wing and a prayer on, oh, well, Mr. Vessel went over this in class. Oh, he didn't go over this in class. Oh, you understand? So all those links supposedly will help you. All right. So I can even put in 1,000 here. What's going to happen?
It's gonna be true.
It still will be true. All right. So sometimes when you're a beginning programmer, you will make those errors. Cause what? You're saying, well, I'm asking if x equal 1,000, right? No, you're not. You're using an equal which assigns it to make it true. But if I simply do that, now I'm comparing if 11 is equal to 1,000. Everybody got that? Okay. All right. So now, then we have the exclamation point equal. And some people, they get confused with that because they'll be on the test. I saw that. I didn't know what that was. When we went over in class, they said the solo learn should help you. This exclamation point stands for not. Okay? So, if x not equal 1,000, what will this expression yield? All right? True or false?
True.
True. All right? Everybody understand that? This will yield true. This says if 11 not equal to 1,000. Everybody got that? All right? All right. But say I do this.
It's not something.
Is it true or false?
False.
Oh, because x is equal to, right? Now, what I tell students is sometimes, just sometimes, based on our culture, and you see it all the time, we use double negatives and we understand each other, right? Computer doesn't do that. Everybody got that? When you code it, the computer will not say, oh, well, they from the South, and oh, well, I understand what they're saying. No, computer will not do that. So you have to be able to, what? Write the code in a manner to where it is correct. You got what I'm saying? Not the way you talk. You know, try to use a lot of your English skills and put them in play because a double negative, you know what I'm saying, it's going to just be a positive. You know what I'm saying? So you got to make sure you put it the way you want it to read. All right? So those are the different operators. Everybody got them. Greater than, less than equal to, greater than equal to, not equal to. right? You understand those, alright? So relational operators. So if I give a quiz on relational operators and give an expression, give values to the variables or whatnot, you all will be able to determine whether it will yield true or false, right? But I won't give it now because we're gonna further on get into compound relations, all right? So let's look at this. All this is showing based upon what we talked about earlier. What this says, read this, somebody. X what?
X.
All right. If X is greater than Y, you compare it. You're not saying that X is greater than Y. You comparing or checking to see if X is greater than Y. Asking a question if X is greater than Y. Right? Look at this. What this says.
If X is less than.
All right. If X is less than Y. All right. So look. Give you the examples. What? X greater than Y. X less than Y. X greater than or equal to. And further on, we're gonna get to that and or, and you're gonna see how that works. Okay. Here you got X less than or equal to Y. X equals Y. Checking to see if it's equal to Y. And if X is not equal to Y. All right. So if we look here, the value of a relationship. All right. So how are relational expressions used in a program? What happens is normally it will return a 0 for false and a 1 for true. All right? Everybody understand that? So when you ask a question if X is greater than Y, the system evaluates that into a value, whether it's 1 or 0, and determine whether or not to do the true or false condition. All right? So, looking at this, a couple of it says because we know what this is and we talked about it. The equal, making sure this is a relational expression. So the equal operator determines whether an operand on the left is equal to the operand on the right. If you use a single equal, I'm saying what? A is equal to 4. I'm assigning. Got to remember that. You got to remember that. All right. So in this one, they're showing that it tests for 2 conditions, whether it's greater than or if it's equal to. All right. You should understand that. If you've taken your math, your algebra or whatever, you should understand greater than or equal to. All right. So look at this. All right. But the following is false. If what is A? A is what? Assuming that A is 4. A greater than or equal to 5. Is A greater than 5? No. Is A equal to 5? No. So those both are false. Alright? Alright? Here are the less than or equal to. Same difference. A less than or equal to C. B less than or equal to 10. What's B? B is 6. Is 6 less than or equal to 10? Yes. So that's true. Alright? But it says this one will be false. Alright? B less than or equal to 8. Is 6 less than or equal to 4? No, it's not less than and it's not equal to, so it's 4. And look, our not equal. That's just comparing to see if those 2 values are the same or equal. And are not equal. If A is not equal B, all right? All right? So A is 4, B is 6. 4 is not equal 6. That's true, right? All right. Now, but it says A not equal C. All right, A is what? 4. C is 4. If A not equal C, is that true? Or false? Huh? A is 4, C is 4. And we asking the question, is 4 not equal C? Right, that's false. All right? Because and the reason why I say about the South, if normally if a person from the South asks, if A not equal 4, yes. It's no. Well, or no, you would say yes, right? So it's not equal, if say, well, A was 3. Is 3 not equal this? You would say yes. But normally what we do when most of the time we ask a question, is this not equal to that? And it's false, we'll say yes for a false answer. You know what I'm saying? So you got to watch, you got to be careful. Alright? So, what is true? Alright? The question, what is true? Alright, is one of the one that you would expect to find in a philosophy book. Okay, not C++ programming text. Alright? It is a good question for us to consider though. Okay? If a relational expression can be either true or false, okay, how are those values represented internally in a program? And I told you 0 and 1. See here, it tells you a 1 is true and a 0 is false. Alright? So, look at this small program and what they did. They created a variable, a Boolean variable, alright, called true value and false value. Right? They assigned X to be 5 and Y to be 10. Correct? Or initialize those variables. Then it said, okay, true val, which gonna be either what? Yes, no, on, off, 1, 0, correct? By the understand, it's Boolean, a Boolean value. So it can only, a bool value, it can only be on, off, true, false, yes, no, right? So when we say true value equals, and we asking the question, if Y is less than, X is less than Y. What's X? Is 5 less than 10?
Yes.
So true value gonna take on the value of what? Would take on the value of what? You only can be 1 and 0, true and false.
1.
1, which is true. You understand? Now look at this one. Is Y, which is 10, equal to X, which is 5. Is 10 equal to 5?
No.
So it's going to assign what value to false value? 0. So when we look down here and it says, see how true is, and then true value, it printed the 1, and then false is, and false value, it printed the what? 0. So it looked at this expression, found out whether it was true or false, and assigned the 1. The second one looked at it, evaluated the expression, and assigned the 0. All right, so that's how it gets the value and determine what's going to be what. All right, so now, and it talks about the true value and how the value expression is solved and then assigned. Okay, it's solved for the expression and assigned. All right. Now, relational expressions have higher precedence than assignment operators in operators. All right. So in this statement, Z is equal to this. So what it's going to do first? This have high precedence, so it's going to solve the expression, the relationship first, right? And then it's going to assign. Correct? But it's all it's saying. So look at this. Z is equal to X greater than X less than Y, right? So what happens? Whatever this expression yields is going to assign it to Z, correct? So what? X is 10, Y is 7. Is 10 less than 7? No, so it's going to assign what to Z? 0. All right, everybody got that? All right, so look at this. See out X greater than Y. Is X greater than Y?
Yes.
So it's going to output what?
1.
A 1. So you understand, it's going to evaluate that expression and either you can output it or you can assign it to a value. All right? And all same thing here. See out X less than or equal to Y. 10 is not less than or equal to 7, so it's going to print out what? A 0. And look at not equal. B is equal to Y, not equal to X. So we got to solve that expression, right? Then assign. So what? Y is 7, X is, and X is 10, right? Is 7 not equal to 10?
Yes.
So we're going to assign that 1, which is true, to B. Question. Everybody understand it? Because once we start coding, you're going to have to be able to pick up this quickly. And because of what I'm saying, you'll get confused when you start adding all these if statements in your program and you wonder, well, how and why and whatever. So hopefully you're catching on to this stuff. All right. So here we go with the if statement. I kind of introduced it to you already, but the if statement, all right? You might think the statement is a procedural program, all right? Well, you might think of statements in a procedural program as individual steps taken, step by step by step by step, all right? All walking down the road. To reach the destination, you must start at the beginning and take each step, okay? One after the other until you reach the destination, all right? The programs you have written so far was that they were sequential, right? You execute a statement, then you execute the next one, then you execute the next one, execute the next one. All of a sudden now, we're introducing what? The if statement. So now what? Depending on our if statement, we might perform a block of statements here, or we might avoid them altogether. So now we what? Maybe skipping information in our program. All right? So, and let's look at the example here. All right? So look here. This is what we're gonna have now. So before we would just execute statement after statement after statement after statement after statement. All of a sudden now we got statement, 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 but then look, is it cold outside? Okay? Now, when you ask the question, class, remember the relational expressions we got? We got either 1 or 0, right? True or false, yes or no. It only can be 2 options, not 3, not 4, not a maybe, not whatever, just yes or no. Mighty got that. So if you were to flow chart a if statement, there would be something like, if it is cold out, or is it cold outside? If it's yes, wear a coat. If it's no, just continue on with your normal day. All right? So that's what this is showing you. All right? So, and Lord, depending on if it's cold or not, say if it's not cold, you're going to skip this process. So it's showing you now what we may be skipping statements based upon values in our program. All right? All right. But now look at this. We can even add multiple statements when we do a if logic. All right? Because look, if it's cold outside, wear a coat, wear a hat, wear gloves. So that means what? We can have multiple statements. Now, I want to show you something about that. Okay? Let me go to online. This class, this program that I've written, you need to pay attention because some of y'all gonna run into this issue. This program that I've written is gonna run, but if I do this, it'll still run. It will still run. All right? This program will still run perfectly. Everybody understand it? It will run. Now, if I do this, if I do something like this, all right, now I do this. If I run this program, it's gonna run, all right? So I'm gonna show you, I'm gonna run it. All right, it's gonna output, well, no, I never, my condition, I'll say equal, all right? So what I'm, in essence, I wanna print out, if X is equal to 10, I wanna print out true. And then after that, I wanna print out what? The program has in it. So let's run it. And it's gonna print out true and program has ended, okay? Now, the reason why the program is okay is because this is the only statement that I want after my if logic, okay? If it's only one statement that you want to execute for a condition, you can just put it, by default, it's gonna execute it and then continue the program. The problem comes when you want to add more statements. Like if I do something like this, now what happens? If X is equal to 10, it's going to print out what? True and
Program has.
And then it's gonna continue. Now, you might say, well, Mr. Vesta, that's what I want the program to do, that's whatever. But check this out. You may not want that to happen. You may want this. If I'm gonna cut this, paste this here, and then I'll say something like, well, no, I won't do that. Because I'm gonna put it back. I want program ended regardless if it's true or false, okay? All right, so I want to print out the program has ended whether or not it's true or false. Everybody got me? So I want it to compare if it's true, print out whatever, end. Compare if it's false, end. Say program is ended, right? Either way I want to print out program is ended. But if I run this, what happens? Okay, it's going to print out true, program has ended, correct? But then if I change this to not equal, my fault, not equal, what's going to happen now? What's going to output? Nothing, right? So when I run it, so how do I get program as ended to print regardless if it's true and regardless if it's false?
Else.
You could do an else, but now you're adding an extra state or adding extra statements. I could do this. Take this out. Hey. So now what happens? If it's true, I'm doing what? Printing out true. Right? And then I'm finishing it, and then what? Printing out what? Program is in. If it's false, it will not do what's in what? The braces. It's gonna print out what? Program. Everybody understand that? And that's one of the keys. Now let's run it now. Okay? It should see program has ended. Alright? And what happens? Students get caught up where they'll say, okay, well, Mrs. Sylvester, I saw code where it didn't have the curly braces. The curly braces is all right to not have if you only have one statement for the if logic. If you have multiple statements that you want to execute, you need to block them. All right? Now, I tell students, being that this is beginning, if you have an if statement, no matter where, if it's just one statement, block it off anyway. The reason being is when you go back to modify your program, you know where your true logic starts and ends and whether or not to put something, whether or not that information goes in there or outside of that. Otherwise, you're going to be confused and you're going to be trying to throw data in certain places, trying to figure out where and what, and then your program can go haywire. All right? But if you have a true logic, and whatever you want to do, curly brace and curly brace. Now, whatever you want to do for that if logic, if it's just one statement, no problem. The curly braces don't matter. All right? Everything in here is going to do. But then I could have 15 other statements that I want to perform based on that logic being true. But I see that they are grouped in that area. All right? I had one. But I know now what, if it's true, I'll put it in between that those curly braces, and I'm not trying to figure out, let me go back and add curly braces, you put them in the wrong place, or you don't put them at all, and then now you got logical error. All right? But, like I say, that's programmer style. You don't have to, but I would say do it because when you start modifying and adding to, you can run into situations. All right? Now, look at this program. This program calculates the average of 3 test scores, all right? And when I say the average, and I think this is one of the ones we did at the beginning of the class where you have to type it in, and then it asks you if it's greater than whatever, congratulations, pat on the back or whatever, all right? So look here. What happens is it allows a person to input 3 test scores, all right? output the test scores. Then what? You calculated an average, making sure what? Your average formula is correct, because no matter what your if statement is like, if your average calculations is wrong, your if logic 9 times out of 10 will be wrong also. Alright? So you see how everything is dependent on each other? So you got to make sure your program is written in the proper order and correctly, so that you can what? Eliminate all those little logical problems. Alright? So now we calculated the average, alright? And then all this doing is setting the format of how the number should look. And then your average is, and then it printed out average. But then look here. If average is greater than high score. What's high score? What's the high score?
95.
Huh?
95.
95. So let me ask you this question. If high score was 95, would it print out congratulations, that's a high score? See, that's something you got to know. You got to pick up on that. All right, let me ask you this question. Is 95 greater than 95?
No.
Huh?
No.
No. So it would be what? False. And so it will not print congratulations. So you understand what I'm saying? When you're writing your code, you're going to have to understand those logical conditions and the expressions to know what your program is to do. Right? Example, if I give you a program to say, validate an input where a number is between 5 and 10. What are the valid numbers? And we dealing with whole numbers.
7, 8, 9.
What's that?
6, 7, 8, 9.
So what you did, what happened? You had to read the problem, and then determine what that range is. So you have, like I say, math skills coming into play. Between. So if a number is between numbers, the actual number that was given are not what? Included. Correct? Everybody understand that? So all those different things, so your math, how would I say it? Your word problem skills in math gonna come into play. You're gonna have to know how to take something that was written and actually apply it, all right, into a program. All right? Now, so look at this. It's just showing us if hours is greater than 40, then it says overtime is true. So this is if it's true, it's gonna perform this. If value greater than 32, see our invalid number. So it only gonna perform this, then continue on with the program. All the other statements is not a part of the if, you just continue on with the program. If overtime equals true, all right? Then what? Pay rate, what did this say? Remember went over this? Pay rate what? Read this out in its long form. Pay rate times equal. Remember we went over this?
Equals pay rate times 2.
Say that again?
Equals pay rate times 2.
Pay rate is equal to pay rate times 2. Remember we went over plus equal, divide equal, multiplication equal, right? Modulus equal, right? So that says pay rate is equal to pay rate times 2. So you gotta know that. Even though you can write it like this, you gotta understand what it is and what it means, okay? All right, this is a key factor, class. Look at this here. It says what? No semicolon goes here. You got to be careful when you write if statement. And some of y'all gonna have this problem. Some of them that not paying attention, gonna have that issue. So what? And what I mean by that is, look at this problem here, all right? If I have this, all right, I'll say, I'll make this 11, right? Or 110. All right, so what should happen here if I run this program? It's gonna say what? If 110 not equal 10, do what?
True.
Output true, then what? Output that, right? What happens if I simply do this? Put a semicolon after the if.
Open error, unexpected.
It's gonna do what?
Gonna do an error.
No, you won't get an error.
Oh, so it didn't expect it?
It's gonna what?
It's gonna say didn't expect it. That's what it says on.
It's gonna what, you said?
Whenever I put something that doesn't belong, it says didn't expect it on the.
It's gonna print out the program has ended.
Go print out, no. What happens is you done cut off or ended your if logic. And all the statements just regular statements after that. So what it's gonna do? It's gonna execute all those statements because you don't have any more if logic. You said if x is not equal to 10 semicolon, bam, I'm finished. Because I put the semicolon. So what it's gonna do? It's gonna output true and then output the program as ended as if they just was standard statement. Okay? Why? So let's run it. And a lot of times students make that mistake and it's like, well, Mr. Lester, I got my logic and my program not running. I don't know what. Look, see here? Because what I did was, once I put the semicolon, I said, this is my entire if logic, period. That's my entire if logic, I'm finished. Now just go ahead on and execute the rest of the program. Give an example, watch this. I'll do something like this. So I'll do something like C out, I'll say BRCC. And I'm gonna just put something to output. And I'll just add one more. All right, so now, I'm gonna take the semicolon out. So now when I run this, what's gonna happen? It's gonna output what? True. BRCC, Baton Rouge, computer science, then it finishes, and then what? The program has ended. If I put a semicolon here, what is gonna output?
All the same stuff.
BRCC, that which.
Everything, because I done said what? I'm finished with my if logic. When I put that semicolon, now just go through the program and execute every statement in the program. So whether I got 100 statements in my if logic divided or one, it's gonna say, if I put that semicolon at the end of that relational expression, it done ended it. Right, so watch what happens. So you see what I'm saying? It printed true, it printed this, it printed that, and it printed that as if it's what? It was just statements, see out statements in the program. No if logic, right? But if I go ahead and take this out, all of a sudden, if it's not equal, well, I'll say, if it's not equal, all I'm gonna get is the program has ended. Well, no, I took my semicolon out. Wait, did I take my, is it 100? No, let me put equal. All right. All right. And I printed that this time because it did this, because it was true, and did that. Now I'll make this equal to be false, because 10 is not, 110 is not equal to 10. It's gonna skip this and do that. So watch when I run it this time. All right? So I'll just get the program as ended. Put a semicolon, and what I should get? I'll get everything printed out. See what I'm saying? Just by adding that semicolon, it just nullified the if logic, the if logic, and just executed the program. Question, all right? So make sure you watch that you do not put a semicolon at the end of, see like here, it's not necessarily a syntax error. It's a logical error in a sense, because now your logic is off. You don't have a comparison. It's just gonna continue to execute all the statements, all right? But it won't give you an error, all right? So, and then I was talking about greater than, if A is greater than or equal to 100, then the number is out of range, all right? So if you put a number less than that, negative, whatever, anything to that side, it'll be wrong. Alright? So, but then look, if A is greater than or equal 100, see out, the number is out of range. Alright? Now, both of these commands or statements are good in that you can have C++ statements all on one line, except for your header files, and it's gonna understand it and it's gonna execute it. You say, well, what you mean by that, Mr. Sylvester? Take this program here. Look at my main. I got int main. I could take this and move this to that line. I can move this to this line. I need to take this out. I could move this to this line. Alright? I can move this to this line. Now, what have I done, class? I made all of my main function one whole line, right? Will that work? Yes, it will. It will run. You know, because it knows where the program. Oh, I got here. Whoa. Let's see. What's the hell? Expected semicolon.
After return.
I must have taken something off. Oh, return 0. Look at return 0. I must have taken the return 0 off. I mean, semicolon. Semicolon. Alright. So let's run it. Alright. Run the program. And it will run. Alright. See what I'm saying? And now, it will run, but it's quite what? Confusing, correct? But, like I say, you can write your code in that fashion because the system will understand, okay, open, close the argument. Or here, that's the start of the body. Here, statement, semicolon. If logic, no semicolon. Beginning of the body. So you understand, it will understand where to start and stop. Notice I don't have any spaces in between my brackets and my command. A curly brace in my command. It will understand it. But it just makes it much harder for you as a programmer to find an error. Okay, what line is on? It's on line 4. Where on line 4? Line 4 runs all the way across here. You understand? So it just makes it that much harder. But it will work. It will work. Now, if I try to do that with multiple like this, then I will get an error. Because now it's trying to look for that header file, and I'm trying to read all this. It should give me yeah, see, now I've got an error. Because it looks at this as just standing by itself. Like you load some type of job or whatever. But, or JCLs or whatever. But it's like you got to have those on lines by itself. But the program itself, you can have all the statements on one line. A couple of them on the same line and whatnot, but it will not give in. They do it now, it's gonna run. Okay, that will run. Alright, so that's all this is showing you. 2 lines here, 1 line. It's gonna work. Alright, but I would suggest not trying to code this way, because now when you need to modify it, I need more than one statement. You gotta open curly brace, close curly brace, add statements in between, and now you get an error. You don't know what line the error or where, you know what line, but you don't know which statement it's on. But it's all programming style, all right? Comparing floating point numbers, all right? Now, sometimes you have an issue with floating point numbers depending on the length of them and whatnot, okay? Now, because of the way that floating point numbers are stored in memory, rounding errors sometimes occur, okay? This is because some fractional numbers cannot be exactly represented using binary, because you can't get the exact number to the T. Look how long that 0.000001. So, you should be careful when using the equality operator, which is the equal to compare floating point numbers, right? For example, okay, this particular program uses two double values, A and B. Both variables are initialized to the value of 1.5, all right? Then the value of 0. Whatever is added to A, all right? This should make A's content a little bit different, right? Should be what? A little bit higher if you add that to it, right? To B, then B. Because of the round off error, however, the two values are still the same. All right. So after a certain length, they're gonna be the exact same value. So here, double A is equal to 1.5, double B is equal to 1.5. But look what they added. They added 0.01 to A. Right? So this plus equal. Now they compare whether A is equal to B, and they what? It end up being the same because it goes so far out and says, okay, well they are the same. So you got to be careful and be mindful of that when you're dealing with numbers with long decimal places. All right. So to prevent the round off error from causing this type of problem, you should stick with greater than and less than comparisons with floating point number. All right, so it's just telling you how to try to avoid that if comparing if they're equal. Okay. Now, back to truth. Okay. Now that you've gotten your feet wet with relational expressions and if statements, let's look at the subject of truth again. You have even seen a relational expression have a value of 1 when it is true and 0 when it is false. In the world of the if statement, however, the concept of true is expanded, all right? 0 is still false, but all values other than zeros are still considered to be what? True. You got what I'm saying? Anything other than 0 yields true, all right? Now, this means that any value, even a negative number, represented for true, as long as it is not 0, would yield true for the expression, okay? So when a relational expression is true, it has the value 1. When the relational expression is false, it has the value 0, okay? Any expression that has a 0 is considered false by the if statement. This includes the val false, which is equivalent to 0. All right. Any expression that has any value other than 0 is considered true. Okay. But the if by the if statement, this includes the bool value true, which is equivalent to 1. Right. The fact that if statements consider any non-zero value as true opens many possible possibilities. Relational expressions are not the only conditions that may be tested, okay? Now, so what happens? All of a sudden now, true can be what? Anything that's what? Anything that's a value other than 0, right? So, let me ask you this question. It tells you now you can test many different things. Say we was doing a payroll, right? We was doing payroll. We have some employees that worked that week, some employees that didn't, and we calculating a gross pay. So I can determine whether or not to print out a record if a person has what? Any amount of money owed to them. Because now I could say what? If, and then I could say gross pay, right? That means if it's anything other than 0, I can what? Print that check. Everybody got what I'm saying? Right? So I could test that value or that variable to see if it's any other value than 0. So if it's any other value than 0, print out the check. Even if the check is a negative value, print out the check. That's what it's gonna do. Anything other than 0. So here, if value, that means what? It's asking if value is true, right? Anything that's what? Not 0. All right? See how it's true. So you see how you can compare variables now. You don't have to just ask, okay, if what? If gross pay is greater than 0, right? Or gross pay not equal 0. You ask if gross pay, and then do whatever you have to do. All right. So that's all it's just telling you. You can do that. All right. And also you can compare 2 different values. All right. If x plus y, all right, that means if when you solve x plus y and you get anything other than 0, it's true. If it's 0, it's false. All right. So see how you can kind of broaden your range to try to do comparisons. All right. Rather than just doing greater than, less than, not equal to, equal to. All right. So, and it tells us here, don't be confused with what? The comparison equal, and the assignment equal. Right? You got to be mindful of that. If I do this, this is going to be true every time. Every single time. This says x is 2 is assigned to x every time it hit that statement. Every time. To solve that, I'd have to put an extra equal. And then now it's comparing to see if x is equal to 2. Everybody got that? All right? You got to remember that. And you will run into issues. All right? Okay. So, all right, this is one with average. Okay, CN3 scores, find the average, and then your average is. And then just credit your average. But remember, if average is equal to 100, all right? Now, if average, now this is not if it's equal to 100. This is assigning what? Average to be 100. So what'll happen when they run that program? It's gonna print what? Congratulations, that's a perfect score. Whether they made a what? A 0 or 100. Any one of those values, right? Everybody understand it? Because I'm assigning average to equal to 100. All right? Now, notice here though, we outputted average where? Here, correct? Before we assigned it. Everybody see that? And what would happen with you is, you would look at your output and say, well, it's outputting 55, but it's out, and then it's outputting congratulations. Why is it doing that? What you'd have to do is go through your logical flow of your program and say, oh, I'm printing out my average prior to doing what? Assigning it that value. All right? So that's where your debugging skills have to come into play. All right? Knowing what's happening before what and whatever. All right? But make sure you do that. Now, okay, it's almost that time. Expanding the if. Now, what happens is with our if, and we talked about it, where you can have what? Multiple statements in the body, and just gonna perform everything in here before it finishes. If it falls in here, it's gonna perform everything. All right. Don't forget your braces when you do the body. Now, on next class period, we'll just pick up here, and we'll start talking about the if else. All right? Because the if else, now what? Rather than just performing what's true and just continuing, I'm gonna perform what's true, or if it's false, now I got something to perform if it's false, and then continue. All right. So class, read up on your notes and everything, right? All right. Yes, I'm Mr. Taylor.
I have a
Where you
question.
been, man?